under carbon-carbon bond making, let's discuss about the formaldehyde technique, right? Which is known as a technique to increase your carbon chain by just one carbon unit, right? So let's discuss about that thing, the Grignard formaldehyde technique, right? Okay, this is about increasing the carbon chain, increasing the carbon chain by one carbon unit, right? Under that, earlier we had discussed about the cyanide technique. Now we are going to discuss about the second technique under that, the formaldehyde, HCHO, or the formaldehyde technique. Formaldehyde technique. Let's do that. Actually, this is at your page number 4, right? Page number 4. After the cyanide method, the note is there, the formaldehyde technique. First, let's discuss how to the theory behind this technique, and then we can do an example conversion, right? So first, the theory behind this technique, right? The theory is like this, Lama. So basically, the point is this. So you can start with the alkyl halide. Like this. See, you are starting with CH3CH2Br, right? So you are supposed to increase the carbon chain of this thing with 1 unit. So you are starting with 2 carbon compound, and you are supposed to increase this by 1 unit. See, you are supposed to come up with a 3 carbon compound, let's say, like that. So if you are following the formaldehyde technique, this is what you are supposed to do, right? First, convert this alkyl halide to a Grignard. Formaldehyde technique uses Grignard, right? First, convert the alkyl halide to a Grignard, right? So you can produce the Grignard reagent by just adding magnesium in dry ethanol. Simple stuff, no? Okay. First use that thing. First convert that thing. Then just add the formaldehyde, HCHO in dry ether medium, and then the acidic makeup. Normally you are using Grignard like this, no? So earlier we had discussed how to use the Grignard with the aldehydes and ketones. So basically, when the aldehyde and the ketone is reacted with the Grignard, that will be done in the dry ether medium. After that, you need to do a kind of acidic makeup, right? The same thing like this. So what will happen? So what will happen here is basically, right? If you add these two guys like this, what will happen is, right, this guy will be removed, that guy will be removed, and instead of that, you will come up with a CH2OH there. You will come up with a CH2OH there. That is this method. So ultimately, one can say, instead of this Br, you just added the CH2OH. Instead of this Br, you just added the CH2OH. That is how the formaldehyde method is used to increase your carbon number by just 1 unit. So Lama, this is not a very new stuff. This is normal stuff, right? If you need to get the idea, I'll write the thing what happened here. It is like this, no Lama? So you had the CH3, CH2, MgBr, right? It's like this, see? CH3, CH2, MGBR was there. I'm just giving you the clear idea here, right? What happened here? And then you had the HCHO. HCHO is what? This is the HCHO. This is HCHO. Right? If you are to connect these two stuff, what will happen? If you are to connect these two stuff, what will happen? So basically, this is your Grignard carbon. This is your aldehyde carbon. HCHO is a kind of aldehyde, right? So what will happen? These two guys will connect. These two guys will connect, leaving the MGBR and leaving this 5 bond. Leaving that 5 bond. Right? And with H plus H2O, this will become a OH. Let's write this stuff. So you have the CH3, CH2. This is your Grignard carbon. To that carbon, this C is connected. This C is connected. That carbon is with two hydrogens. That carbon is with two hydrogens. And this O becomes OH after adding the H plus H2. So CH3, CH2, CH2OH. This is a new group added. See? Got the idea? That is what happened here. So one can say instead of the MGBR, you just added the CH2OH group. You just added the CH2OH group. Instead of the MGBR, you just added the CH2OH group with H plus H2. With H plus H2. Right now? That's it. Right? Mixed in dry ether medium. Mixing dry ether medium, dry ether mixing, and H plus H2O will produce this. Right? So this is the formaldehyde technique. I'll do example conversion for this thing as well. I'll do the same conversion we had completed with the cyanide, right? With the cyanide method, right? As an example for this one as well, right? Let's do the stuff, right? Cyanide method දෙන් කරපු මේක දුක් කළා දාමු. ඔන්න නේද? හරි? Let's do the stuff, same stuff, right? කතා පැහැදිලි? See? Formaldehyde technique. So let's do example conversion. Right, let's start with this one. This is your conversion. So you have some group like this, and you are supposed to produce this one. CH3 and some OH there, no? Okay. Let's analyze this conversion. Let's analyze this conversion. So I'm going to use the formaldehyde technique here, right? Okay. See, our first task is to come up with the correct carbon skeleton. Our first task is to come up with the correct carbon skeleton. After completing that task, only we are trying to come up with the correct functional carbon, and after that is completed, we will do the changes in the functional groups, the makeups, right? Okay, first of all, come up with the correct carbon skeleton, right? So you will see 3 carbons are appearing at the starting compound. At the end compound, you would see 1, 2, 3, 4 carbons are appearing, right? So 1 carbon is added. 1 carbon is added. So what is that 1 carbon? So you have a straight chain here. You have a straight chain here. But here you have straight chain as well as a branch there. So this is the new carbon which is added. This is the new carbon which is added. So I am going to use the formaldehyde technique. So this is the carbon coming from a formaldehyde. This is the carbon or section. coming from formaldehyde, HCHO. Right now? Okay, then let's complete the stuff. So the formaldehyde carbon, right? Formaldehyde carbon is this, and so that this carbon should be then a Grignard carbon. Should be a Grignard carbon. To a Grignard carbon, the formaldehyde is added. To a Grignard carbon, the formaldehyde is added. So this is the formaldehyde carbon. This is the formaldehyde carbon, and this is the Grignard carbon, right? Okay. So it should be added to a Grignard carbon. No? So first of all, you should come up with this Grignard. So this is your Grignard carbon. No? That is your Grignard, right? No? So let's do the conversion. Let's try to come up with the correct carbon skeleton first of all, right? So the formaldehyde section should be added after making a Grignard reagent. We have the MgBr attached to this carbon, right? Let's do the stuff. So first of all, you have to come up with this alkyl halide functionality to here to come up with the Grignard here, right? So let's do the conversion. So first of all, we can come up with a double bond to change the functionality towards the center. So that can be done by alcoholic KOH. Then, right, we can come up with some Br there. So I'll write the Br here, right? Just HBr addition, substitution of so just yeah, HBr addition, right? So then you can come up with the Grignard. By just adding Mg dry ether, Mg in dry ether medium. So CH3CH, right? Then we can connect the new carbon, right, as a CH2OH by adding some formaldehyde there, HCHO in dry ether, N2 H plus H2O. When forming alcohols with the use of Grignard, this method should be followed. The two things should be mixed in the dry ether medium, and secondly H plus H2O, that acidic makeup should be done. So there, what will happen? This MgBr leaves, and this converts to CH2OH, coming from here, right? So it's going to be CH3 to here. It's going to be CH2OH, right now. Okay. Then you can add you can come up with double bond here. Now actually coming up with the correct carbon skeleton is done. The first stage is done. Coming up with the correct carbon skeleton is done. Now you have with the T-shaped carbon skeleton. The first task is done. Now we need to come up with the second task. We need to complete the second task. Sorry. The second task is actually coming up with the correct carbon as the functional carbon. So still the functionality is at here. Now we need to convert it to here, right? So we need to bring the functionality to here, right? So coming up with the correct functional carbon, right? Here what we have done was, sorry, functionality here, right? Okay. So now we need to copy the function to this carbon, right? So that can be done by the H2O technique as well as the HBr technique. So when we can release some water molecule there, right? Okay. Done. It will be done by some conc H2SO4 and heating. Finally, you can do this step of adding a water molecule by just by adding a tilde H2SO4. Right now, so things are done. The hydrogen will be added to the carbon with more number of hydrogens, so that it will be converted to CH3, while the OH will be added here. Right now, so it's just a simple conversion. So if you know the finite technique, this is very easy, right? Not that much hard, right? So here some CH2OH section will be connected to the carbon which earlier carried the MgBr, right? Okay, no? So this is the formaldehyde technique, right? This is the formaldehyde technique.